Network is 192.1.13.0, area 0. The other networks like 33, I'll say is area 20, 3, area 20, and I'll say 35 is area 20. 1, 2, 3, 4, 5, 4, 1, 2, 3, 4, yeah, that's good. So now I should see some routes, some OIA routes, some O routes. 22 and 24 are from area 10, that's why they're coming in as IA routes. So that's done. Let's go router 4. This particular router, if you look at your diagram, is completely in area 10 over here, with a whole bunch of loopbacks over here. So router's done, network 4000, 10, network is 444, and then the 204 networks. Show IP route, OSPF, I should see a bunch of O and OIA routes. And if I go to router 1 now, I should also see some OIA routes for OSPF, including the 204 routes. Good. So that takes care of this guy over here completely. Now we're almost down towards the last area of OSPF, which is area 20, R5 and R6. Let's check R5 and R6. R5, all the interfaces in area 20. R6, some interfaces I'll put into OSPF area 20, the rest in RIP. I want something in RIP as well. All right, so 1.35.0. .56 is done in area 20. Then I have 5. And 55. Then I have the 205 networks, and I'm done. So a bunch of OSPF routes. We'll just do OSPF. And router 1, now I should have the 205s as well. There you go. 204s, 205s. Router 6 now. Router OSPF 1, router ID, let's say is 66. Network is 56.0. Area 20. We'll put 66 down here. We will put 69. Actually, that 69 I need to put over there. This is good enough. So I should see a whole bunch of OSPF routes in. Now that's 6 done. 7 was done. Also on 6, I'm going to do RIP. 69.0, and we'll say 6.0. And the last router, router 9. Show IP interface brief. Router RIP version 2, no auto. Network is 69.0 and 9.0 and 99. I should see some rip route. There's one. And on 6, I should see some rip route. There's a couple. So my topology is done. The last thing that I want to do over here to complete my requirement, over here, complete my topology, is do the redistributions. Where are the different points of my redistributions over here, guys? And what type of redistributions am I going to do? 1 and 6 as well. On 1, I'm going to do static routes into OSPF, EIGRP into OSPF, and OSPF into EIGRP. But I also need to do it on R6 between OSPF and RIP version 2. So let's go ahead and do that and have a complete topology with all the different routes. So let's say I'm on router 6 right now. Might as well finish that off. In OSPF 1, redistribute RIP, subnets, redistribute OSPF 1, metric 1 into RIP. So now if I go to 9, I should see a bunch of different routes. All right. And similarly on 1, route OSPF 1, redistribute static subnets, redistribute EIGRP 100 subnets. Router EIGRP 100, redistribute OSPF 1, metric 111, or just get used to this 1010 just in case you were using the named one. Redistribute static does not require metrics. So now even if I go to 7, I should see a bunch of different routes. Clear? So my entire topology is set up between what? Between all the different routers. Everyone should be able to reach everyone. Let's go to 9 and be able to ping 7, 8, or router 4, for example. So that would go from edge to edge. So if I go to 9, ping 8888, 7777. I don't think I have 7. I have 77, I believe. There you go. And ping 4. Good. The objective over here was not to set the topology up, but I needed you guys to see it, to see how the topology is set up. The main thing that I want to do today in terms of OSPF are these particular topics. And I'm going to take a look at these topics one at a time. Let's start with the first topic that we have over here, which is route summarization. Route summarization allows you the ability to take multiple LSA type 3s and summarize multiple LSA type 3s into one. One of the things that people get confused about is the difference between route summarization and LSA summarization. If you guys remember, yesterday we took that network 100, which had multiple type 1 and type 2 LSAs, and we got it into what? A single type 3 LSA. You guys remember that? So let's say this network over here was, let's say 204.1.4. I had multiple type 1, type 2 LSAs for that network. I converted it into a single type 3 LSA. What is this called? This was called LSA summarization. Agreed? And then I would do the same thing for 204.1.5.0. I would do the same thing for 204.1.6.0. 204.1.7.0. These would be a multitude of what? Type 1, potentially type 2. Each route would have its own type 1, type 2s, potentially, depending on what type of route it is. And those get summarized into a single what? Type 3. But how many type 3s do I have over here? For every route, I have a separate what? Type 3 that goes in from one area to the other area. Everybody okay with this? You understand what I did over here? You guys clear? So I took multiple type 1, type 2s, and I converted them into a single type 3, which is done by the ABR and sent across. Done? How many type 3s am I sending? I'm sending 4 type 3s. Although I have multitudes of what? Type 1, type 2s, which were converted into a single type 3 for each one of those routes. But I do have multiple type 3 routes. Although the LSA summarization for the summary LSA is done automatically, I do have the ability to take multiple of type 3 LSAs, if they can, and summarize them into a single type 3 LSA. This is manual, and this is called route summarization. The same type of summarization that we took a look at for what? RIP NEIGRP can be done in OSPF as well, but it is done by taking multiple type 3 LSAs and sending a single type 3 LSA for all these 3 or 4 LSAs that you have over here. That's called route summarization. Everybody okay in terms of the difference between LSA summarization versus route summarization? How about the other guys? Jopin, Farhan, Shram, Mohammed, Rami, Hana, all good? Siraj. All right, now, the next thing that I want to do over here is show you how it's done and some of the limitations that you have. This conversion of multiple type 3s into a single type 3 is done at a place that these LSAs are getting injected into OSPF. And where is that? Where do I actually inject, or who generates these type 3 LSAs? The ABR does. So summarization in OSPF is only possible on the ABR. It's for 2 reasons. Number 1, you cannot do summarization of type 1, type 2 LSAs. You cannot filter type 1, type 2 LSAs. In a single OSPF area, the requirement is that they share the same OSPF database. The LSA database of OSPF has to be the same. So if it has to be the same, you cannot filter it. So there's no filtering that's allowed for type 1, type 2 within the area. And if you really look at it, summarization is a form of filtering. Have you guys thought about it? When you do summarization, it is a way of filtering it. How do I say that? Why do I say that? If I send a summary address out, rather than sending out 4 routes, which route am I sending out? A summary route. What did I do with the specific routes that fell under that summary? I blocked them. I suppressed them. You guys agree? So that is not possible in OSPF within the area. You cannot suppress or filter any routes within the area, because the whole premise of an area is that the area needs to have a common database. You cannot do any type of filtering for an area within the area. It can only be done on the borders when it's sending the route from one area to the other. So for that reason, the summarization in OSPF is limited to only on the ABRs. When we take a look at from a design perspective, this becomes a limitation, because within the area you cannot do any type of summarization. Summarization is only possible on the ABR. So for only one LSA, yeah, if you do the summarization manually, you have the ability to take multiple type 3 LSAs and send a single type 3 LSA for that. So route summarization is taking multiple type 3s and injecting a single type 3 for them. Whereas LSA summarization takes multiple LSA type 1, type 2s and sends in a type 3 for them. You get my point? So for example, over here, if I do have the ability to summarize, like I have 204.1.4.0, 5.0, 6.0, 7.0 in area 10, If I don't want to send all 4 routes, I want to suppress them, I do have the ability to do it, but I can only do it on the ABR. And when I do that, rather than sending 4 LSA type 3s, I'm going to send a single type 3. Everybody okay with that? Hitesh, you got it. Any questions about that? So in terms of summarization, OSPF is not the best. RIP and EIGRP give you more power because RIP and EIGRP allow the ability to summarize on any router, whereas OSPF you can only do summarization on the ABR. So when you're comparing protocols, that is a limitation of OSPF. Make sense? Everybody okay with that? Let me show you that. See over here, if you take a look at router, let's go to router 1. Show IP route, I'll say include 204.1. How many LSA type 3s do I have over here? I have 4 type 3s coming in. 204.1.4, 5, 6, and 7. I can check that as well in my database. Show IP OSPF, database, summary. And you should see the 204s coming in. The 204.1, 204.4, 5, 6, and 7 right here. These are 4 different type 3 LSAs that are coming in. Good. They're being, who injects it? The ABR, which is router 2. So what I have the ability to do is go to router 2 and summarize them. Which routes? The routes were coming into my OSPF database as O routes. So I'm going to take these O routes, which are type 1, type 2 generated routes, and I'm going to inject them into area 0, but at the time that I inject them into area 0, at the ABR, I'm going to inject the type 3 LSA. Now I'm going to have 4 type 3 LSAs over here. Now these 4 type 3 LSAs, if I want to summarize them, the way you do that is under the router OSPF process, I would go in and I would say area, the source area where the route is being generated from. Where's the route being generated from? Where are these routes? 204, 1, 4, 5, 6, and 7. Where are these routes at? They're O routes that are coming into router 2 from this guy over here. The 204, 1, 4, 0, 5, 0, 6, 0, 7, 0. All these routes are coming from a router 4, which is injecting it into router 2. Router 2 receives it as type 1, type 2s. Actually, in my case, it's just type 1 because it's a dead-end network. And it injects a type 3 over here. How many type 3s? For every route, it's going to be a separate type 3. So I'm going to have 4 type 3s for these 204s. Now, what I'm going to do over here is I'm going to say I want to summarize the routes. And when I do the summary command, I need to specify the source area where the routes are coming from. They're coming in from area 10. So I'm going to say area 10, followed by the range command. Keyword is range. And then my summary address. As soon as I do that, now I'm no longer going to send 4 LSA type 3s for 4, 5, 6, and 7. I'm going to suppress them, filter them, and only send a single summary for the 4 routes that are in question. So right now, if I do the show IP route include, I just have 1 single route over there. And if I look at my database, I will not have the 204, 5, 6, 7, and 4, 5, 6, and 7. I'll just have 1. And which is going to be the 204.140 network /22. All right? Clear? Everybody okay with that? Where you do it? You do it on the ABR. Let me write this down for you guys. Summarization in OSPF, summarization is only possible on the ABRs. This is due to the fact that OSPF requires all the routers within the area to have what? A common database. This means that there should not be any form of filtering. Route summarization is a form of filtering. You understand what I'm saying? I'm not sending 4, 5, 6, and 7. I'm sending a summary route that is representing the 4 routes, but I'm suppressing the other routes, which is the suppression. All right, so how do I do it? The configuration part of it. Route OSPF1, area XX, range, and the summary network, summary net, followed by the summary mask. Clear? Example of that was router OSPF1, range, now which ABR do you need to do this on? The ABR that you need to do this on is the one that is connected to area 20. Area 10. For example, I'm also, if you look at here, I'm getting a set of routes from 205. I'm getting 4, 205, 1, 4, 5, 6, and 7. These routes are getting originated from R5 over here. Okay? They're getting sent into area 10. Can I summarize these routes on R2? Let's check. If I go onto R2 and I say area 20 range 205.1.4.0 255, 255, 252.0, I've done the summarization. If I go to router 4, show IP route include 205.1, no summarization is taking place. So where do I need to do this summarization on, even if I'm doing it? Which ABR? Which ABR do I need to do the summarization on? You guys there? ABR at the right. The one that is where the actual routes are getting propagated from. Three, what do you mean by 3, Jopin? R3, yes. Correct. On this guy. So I purposely try to show you guys that if you do summarization of area 20 routes on this ABR, it's not going to work. It has to be done on the actual ABR for that particular area. So if I want to summarize routes from R5, they need to be summarized where? Over here. Not over here. It's not going to work. Clear? Everybody okay with that? So summarization for any routes in area 20 have to be done by the ABR that is connected to it. All the summarization for area 20 needs to be done by this one, the ABR for area 20. Make sense? So if you want to fix that, we can do that over here. We can go back over here onto router 2. I can take it off, it really doesn't matter. Go to R3. Area 20. Yeah, 204 needs to be done on R2, correct. And that's what I had done. I done R2 for 204, and I'll do 205 on R3. Now, if I go back over here on R1 and I do show IP route include 205.1, there you go. If I do this, I have that. The summarization is done on the appropriate ABR, not just any ABR. So now I just have a single route. I still have reachability to it. Now, one thing that you also need to understand about summarization, which is sometimes overlooked. So for, let me finish this over here. Summarization needs to be done on the ABR for the area where the routes reside. So not on any ABR, in the area where the routes actually reside. Okay. The other thing that you need to understand about summarization, which is very important from the design perspective. What is the benefit of summarization you guys see over here? What was the benefit of doing summarization over here, the way you look at it? Smaller routing table. Low memory, small routing table. What about conversions, Hitesh? Faster, yeah. The one those are all good. They're all part of the advantage of summarization. I'm not denying it. But one extra thing that you also need to take a look at is this. Not this one, sorry. Where is that? Flapping. Muhammad said that. What is flapping? Let's say a route has a bad cable and it goes up or down. Anytime it goes up, it will tell everybody, hey, listen, my network that I told you about is down. It flaps, it comes back up. It tells everybody, listen, the network that this particular network just came up. So it tells them about the up and the down. And if it's flapping, flapping means what? Going up or down. It is going to affect the entire OSPF domain, because every time it goes up, it will tell its neighbor, neighbor will tell the other neighbor, neighbor will tell the ABR, ABR will tell the other routers. Everyone in the OSPF domain will find out about it and will have to rerun the SPF algorithm, which causes the CPU to be utilized heavily. Every time you run the SPF algorithm, the router needs to go into its LSA database, figure out which is the best way to get to this particular route. Or if it has lost a route, it needs to see if it has another way to get to that route. Do you get my point? So if you want to isolate the problem of a flapping route to its own local area, summarization is the only and the best way to do it. Because let's say there's a flapping route in here. Let me go to this diagram over here. If I have a flapping route over in area 20, let's say that one of the routes, let's say 205.1.7.0 is a bad network, is going up, down, like that. Every time it goes up, it will tell him, hey, it's up. It goes down, it says it's down. When it says that, he needs to run the SPF algorithm to figure out if it's down, which is there any other route for it? No, there's no. Okay, fine. But it still needed to run it. When it comes back up, it says, oh, new route came up. I need to run the SPF algorithm, let everybody know. It floods it to the entire domain. He will tell R1, R1 will tell R2, R2 will tell R4 that this route is up or this route is down. You guys okay with that? So when a route goes up or route goes down, it is notifying everybody in the domain that the route is going up and down. Clear? But if I summarize it, if I summarize the route, let's say I sent what out when I did the summary over here? What route did I send out? This route. You guys agree? I sent 205.1.4.0/22. If this route is flapping, going up and down, yes, it will cause the SPF to be run within its own area. But because R3 never send 205.1.7.0 to anybody, it sent the summary route, it will not let him know that the route went down because there's other routes in that particular summary that are still up. So it doesn't need to tell him, hey, listen, 7 came up or 7 went down, 7 came up, 7 went down. It would not need to tell everybody about it. So it allows you to do fault isolation. So if a particular route is flapping, you have the ability to isolate that fault within that OSPF area. That's an advantage of an OSPF area where you have the ability, using summarization, to isolate the problem to a particular area. Are you guys okay with that? Which is something that, as a designer, when you design a network, which becomes a very, very important consideration. Yes, the smaller routing table is good. Less memory is good. This is an advantage of anything, any summarization, not just OSPF. It is better for OSPF because better in the sense that EIGRP would not be that big of a deal because all it needs to do is go into the EIGRP topology table, pull the route and put the backup route in, which is a quick process. With OSPF, because it needs to take a look at the entire database and figure out which is the best way to get there. So it's a more CPU intensive protocol. So it takes more out of the router if there's a flapping route. But in terms of doing, having this as an advantage of EIGRP, absolutely. It's an advantage of summarization, not just OSPF, but with OSPF, because the amount of stress it puts on the CPU for doing this, it is, it is even more important to do it in OSPF. So summarization can hide the actual route. Yes, it is. It's basically giving us a common route. So it's not giving the specific route to the outside networks, outside its own area. Does that answer your question, Dawood? So when you look at it, yes, it is an advantage of summarization, but for OSPF, it makes a better and bigger impact. True, very true. Yeah, summarization in general is the same. The only difference is that with RIP and EIGRP, I could do it on any router. With OSPF, because that concept of a single common topology within the area, you cannot do it within the area. It has to be done from one area to the other. So, but the other advantage that I talked about is good for both. We should sum where we can. Yes, we should summarize wherever you can. Good. So when you're looking at it from a design perspective, always take a look at that when you look at it. But the thing is, it doesn't do it automatically. You need to do it yourself. It is only manual summarization. There is no auto summarization in OSPF. Anyways, auto summarization is something that can cause problems. I will always stay away from it anyways. It's not something that I'm a big fan of anyways. All right, so that took care of summarization of what? OSPF routes. Where are OSPF routes summarized? On the appropriate AVRs. Now, one more thing that I want to bring into the table over here is the summarization of external routes. Now, external routes, when I did the summarization of routes on router 2, what did I do? What was the command? Router OSPF 1 area, source area where the routes are originating from. 10. The command was range. And then whatever the summary and the mask was. Agreed? What area do external routes belong to? What area do external routes belong to? If I want to summarize them, can I use area x range command for that? I can't, because they do not belong to any area. They don't originate from an area. They're external routes. They're coming from another domain. So if I want to summarize external routes have to be summarized on the ASBR. Just like you needed to summarize routes from area 10 on the appropriate ABR, which is router 2. I needed to summarize routes from area 20 on this particular ABR. Similarly, if I want to summarize external routes and the routes were coming in from EIGRP and OSPF, I need to do it on this ASBR. If the routes were coming from RIP, I would need to do it over here. And the command is different. It is not area X range because they don't belong to any what? Area. So what is the command to do that? Let's do a before and after for that. So if you take a look over here on router 2, I should have some 207 routes that I had created. There you go. I have 4 external routes, 207, 1, 4, 5, 6, and 7. 207 is coming from router 1. So that's my ASBR for these 4 routes. Router OSPF 1. The command is not area X range. The command for external summarization is called the summary address command, which is done on the ASBR. So I would do this. So if I want to summarize my external routes, again, it's a good thing to do summarization again for 2 reasons. 1, cutting down on your routing table, which takes less memory and all that, but also for the purpose of flapping routes, protecting one domain from another. Summarization needs to be done on the ABR where the routes actually reside for OSPF routes. Route summarization for external routes needs to be done on the ASBR. All right, on the appropriate ASBR. It is done using the summary address command. All right, so I would do it like this. This is for OSPF route summarization. This would be for OSPF external route summarization. This is always on the ASBR. We did 207.1. All right, so you need to understand where to use the summary address, where to use the area command. Now, if you want to see the result, I can check the same router. Which router was it? To this one. See, now I should only see one route. But I would not be able to use the commands interchangeably. I need to use the area command for OSPF routes. I need to use the summary address command for external routes, whether it's EIGRP, whether it's RIP, it doesn't matter. Where on the appropriate ASBR. Everybody okay with that? So you need to understand that where would you use the summary address command, where would you use the area X range command. Area X range command for OSPF route summarization, summary address command for external route summarization into OSPF. Clear? Everybody, if you guys are good, we are done with the first topic. All right, so let's take a look at the other topic, filtering. What did I just tell you about filtering? Filtering is only possible where? In OSPF, only on the ABR. Yes, also on the ASBR if you want external routes. For OSPF, it's only possible where? On the ABR. Why? Within the area, you need to have a common topology view. You cannot have a different view of the topology on different routers in OSPF. So the filtering is only possible on ABRs. Just to give you an example of that. And that's, you can do it, but it can be very cumbersome. I have router 1 over here, router 2, connected to each other. 12, 23, there's 1, and there is 3 over here. What's the first thing that gets exchanged between the routers? Is the LSA database, right? And as I told you, within the same area, the LSA database needs to be the same. So the LSA database for all 3 routers will be router 1 has 2 links, 1 and 12. Router 2 has 2 links, 12 and 23. And router 3 has 2 links, 3 and 23. This will be consistent within the area. And that's what gets exchanged between the different routers. It doesn't exchange routes. It exchanges what? The LSA database. So this is what's going to be exchanged between the routers. The LSAs, right? Eventually, everyone will have the same LSAs. Once this is done, as I told you, OSPF runs the SPF algorithm, figuring out the best route because it has a full view of the topology and takes the route and puts it into where? It puts it into your routing table over here. So this is your routing table. In your routing table, you would have that over here, 1 is connected, 12 is connected. It would see OSPF 23 and OSPF as 3. This guy over here will see 12 and 23 connected. It would see 1 and 3 through OSPF through different routers. Here, you would see 3 and 23 connected, and you would see 1 and 12 through OSPF. You guys agree? By running the SPF algorithm, I will get that. Now, one of the things, if you wanted to do, let's say you don't want router 2 to receive network 1. Block 1 on R2. How did I block on RIP and EIGRP? You guys remember? Remember we did filtering for RIP and EIGRP? No, not passive. Distribute list. Passive was for not sending updates on specific interfaces. Distribute list using a prefix list or distribute list using an ACL, right? The distribute list in terms of the placement over here, it can be done in OSPF, but it places it over here between the LSA database and the routing table. So if I go over here and block 1 on router 2, I can do a distribute list over here, which goes between the LSA database and the routing table. So if I say block 1, he will take out 1. That is possible. But that still keeps my rule, which says my OSPF database needs to be consistent, because I didn't do any filtering for LSA type 1, type 2. So this guy and this guy and this guy will all see the same thing. They will all know their own topologies. That exchange of LSA type 1, type 2, I cannot block. So R3 will still receive this LSA database, and he, based on the LSA database, will figure out the entire topology and say, okay, one is reachable over here. So although you blocked it on R2, R2 should not have sent that route to him, but he's never sending the route. He's sending the LSAs. LSAs cannot be blocked. LSA type 1, type 2 cannot be blocked in OSPF. Common view. Remember that common view statement that I've been making? The common view needs to be maintained, and that is maintained by not blocking type 1 and type 2. This can lead to black holing. What do I mean by black holing? This router still thinks that one is reachable via what? R2. He will send the packet. He will actually send the packet to R2. R2's routing table doesn't have it. He will drop it. But you'll still utilize a link between R3 to R2 to send the route. He thinks the route is there, and he thinks I don't have it. So it's not recommended to do filtering within the area. The whole purpose of an area is a common view of the topology. Does that make sense, guys? You guys good with this? So within the area, you shouldn't do it. Can you do it? Let me just show you what happens. Just briefly. Remember, I have those 3 routers in area 20. I have 3, 5, and 6. So let's say on 3 or on 5, I want to block 6. So I'll go to 5. I'm showing you what you should not do. All right. I have 6 over here, 600. See this? I want to block it. No, this is external, sorry. I want to block the 632. It's a /32 route, so I'm going to go over here. Let it come in as 66. It's easier to do that. So now if I go over here, I should see 66 with a /8. Give it some time. There you go. Do you see that? Now I want to block it. How do I block it? Let's just use an ACL. Deny 66.0.0.0.255.255.255. Access dash list 1. Permit any. Route OSPF 1. Distribute dash list 1 in E01. That's the interface facing R6. Show IP route. Include 66. It's gone. But how about my LSA database? Show IP OSPF database router. Still there. And it will propagate that to R3. R3 is the next router over here. So if I go to R3, six should be sending. Because the LSA database shows the entire picture of the area. It says, oh, I know how to get to 66s via R5. But R5, when it sends it to there, so he has it in the routing table, he will try to ping. It's not going to go. Why not? The router in the middle is going to say, hey, I don't have it. Although R3 thinks it's there via R5. It's not a good thing to do in an OSPF area. Again, use the OSPF area where you have a common view of the entire network. You guys clear on that? So what type of filtering can you do in OSPF then? Well, do it on the ABRs. You have the ability to block on the ABR. So I'm going to take this off. It's something that I want you guys to see, but don't do it. No distribute dash list 1 any 0/1. So now if I go to router 3, my ping eventually should work. There you go. Okay. Now what type of filtering can you do? Now what the type of filtering that you can do is when you're sending the routes from one area to another, which is basically type 3, or vice versa, into the area or out of the area. Whenever you do filtering in OSPF filtering is for type 3, okay, from the area perspective. What do I mean by areas perspective? If I don't want a particular route, a particular LSA to come into the area, I'll do it from areas perspective. For example, let's say I don't want to allow network 55 should be blocked. In what? In area 10. Where do I do the block? Where can I do the block? The block has to be done on the ABR. As I said, the filtering is only available for me on the ABR. Now, if you're doing it on the ABR, is the router sending the route into area 10? Or is it receiving the route from area 10? Should I do filtering inbound or outbound? Inbound into router 2 or inbound, outbound out of router 2? Out towards R4, right? But when you do it, you don't do it from the ABR's perspective. You always do it from the perspective of the area. Although it's leaving the ABR and you're doing the filtering on the ABR, you always do it from the perspective of the area. Is the route getting sent into the area or is it going out of the area? Area. The key over here is, I'm stressing it, it's the area. It's not the router. So if I don't want a particular route entering an area, even though it's leaving the ABR and you're doing the configuration on the ABR, the direction will be inbound. Routes entering the area, if you want to filter them, you do it inbound. If you want to filter routes leaving the area, you do it outbound on the ABR. Do you get my point? So it's not from the perspective of the router that you're doing it. Look at it from the perspective of the area you're doing it. So if you want to put yourself inside a device and do the filtering, you're not doing it inside the device. You're doing it by looking at it from the perspective of the area. So you put yourself in here and say, is the route coming into the area or is it going out of the area? And that's what the direction will be. The other restriction of the filtering for LSA type 3 is it's only available with prefix list. Okay, you cannot do it based on ACLs. So LSA type filtering is only available with prefix list. You guys okay with that? So let me write this down for you guys. Filtering is possible in OSPF at the ABR for OSPF routes. Which routes? It is only possible for type 3 routes. It is done from the perspective of the area. It is done using a prefix list. All right, so let's do this request or this specific scenario that I wanted to do. I wanted to block in area 10, I wanted to block that 55 route. Do I have 55? I have 5500/8 right now on R4. Where's R4? Oops. R4 is right over here. Makes sense. I want to block area 10 to get 55. Where would I do it? On R2. IP, prefix list, whatever you want to call it, ABC. Deny 55/8. IP prefix list ABC. Permit 0000/0 LE32. Remember that? Deny 55, permit the rest. How do I apply it? Area 10. Filter dash list. Prefix, the keyword prefix. There's no other option. You can't do an ACL. And the name of the ACL, the name of the prefix list. We call it ABC. And then the direction. In or out. I'm going to do it inbound into area 10. Does that make sense? From the perspective of the area. So if I go to route of 4 now, I would have lost 55. Do I have 5? Yeah, I still have 5. I could also do it outbound. If I wanted to do it outbound, I didn't want our network 5 to leave area 20. Where would I do it? If I didn't want network 55 or 5 to leave, you would need to do it on R3 in what direction? Outbound from area 20. So if I go to router 1 right now, even for that matter router 2, router 2 will still have 55 because it's also part of area 0, so it's going to have 55. But let's say I don't want 55 to be leaving area 20 at all. Then in that case, I would have done it over here. Area 20. Filter list, prefix ABC, out. Now if I go to router 2, gone. Or router 1 for that matter. You guys okay with filtering? So filtering can be done where? On the ABR, either inbound or outbound. Unlike the summarization, which needs to be done on the ABR, which is close to the originating routers, filtering, LSA type 3 filtering can be done on any router, on any ABR, sorry, not any router, on any ABR. So for example, over here, 55, I blocked it on what? On R2, although the route actually originated from area 20. That's absolutely okay, because it's the responsibility of the ABR to specify what route should enter or leave that particular area. You do have the ability to do that. So if there's a requirement of doing that, you can do it if it is on the, if the requirement allows you the ability to do it on the ABR. Does that make sense, guys? Everybody okay with that? Clear? So let's put the syntax over here real quick. Let's do it R3. R3 would have been what? IP prefix dash list ABC deny 55000/8. Area 20 filter dash list prefix ABC out. Or you could have done it where? Same filter list, but it's just in a different location. You guys okay with this? Now, filtering with redistribution. External routes. Can I filter external routes? For example, let's say on 7, what routes do I have? Let's add 7 over here. So I have 7 advertised as well, show IP route, EIGRP. I have 7 and 77. Now, 7 and 77 are getting redistributed by what? Actually, I'll hold on to that because when I do redistribution, if you remember from my outline, where's my outline? I will do that under my redistribution with route filtering. So I'm going to hang off that. I need to do that anyways at that point, so I'll do it at that point. We've done this already in terms of redistribution, LSA type 4 and 5. We'll do this at that time, manual as well as route tagging. Clear? So our filtering portion is done as well. The next one and the last one for the evening is OSPF area types. For this, I want to build up a scenario over here. Do you guys remember this? This is what I have. Now, hypothetically, I'm not saying it's there, but let's say I had 200 EIGRP routes over here. Okay. Let's say I had 50 static routes over here. This number over here is the number of routes. Follow along, guys. This is important. Pay attention. This is the last thing for the night. Let's say I had 25 routes over here. This number is the number of routes. Let's say about 100 100 routes exist over here. Let's say 150 routes exist over here. Okay? And in RIP, let's say I have 50 routes over here as well for RIP. So this number 200 represents the number of routes. 50 routes, 25 in area 0, 100 routes in area 10, 150 routes in area 20, and 50 routes in RIP. Guys, important, so pay attention. Help me out with the routing table of area 20. What does it look like? What do I mean by what does it look like? What I mean is, how many O routes would I have in here? O are routes from the same area. I want answers, guys. 100. Brilliant. How many OIA routes, inter-area routes, would I have? 25 plus 25 plus 150 is 175. How many external routes would I have? E2 routes. $300, right? So my total routing table looks like this on area 10. Oh, what happened? I hate this. Jeez, man. Need to do it again. 1 minute. So O we said were 100. OIA 175 and OE2 was 300. Total was 575. Good? Clear? How about this guy over here, area 20? Help me out with that. You can do it quicker. O 150. You guys agree? OIA is 125. OE2 is the same. The number of routes is the same. Just the breakdown is different. Everybody okay with that? Now, one of the things that OSPF does give you the ability to do is a special type of filtering where you have the ability to filter external routes into an area. Where did you get 125 for what? For OIA? $25 routes and 100 routes. In area 20, these routes will be inter-area routes. Right? You get that, Reza? And over here, it'll be 175 because 25 plus 150. Now, one of the things that OSPF allows us the ability to do is create special type of areas, which are called area types, or it gives the area special designation with certain characteristics in it. The first designation, first characteristic that you have the ability to do is called a stub area. It has a designation, it has a certain characteristic. Let me put that characteristic to you. The characteristic of a stub area. My first area type is stub. It has two characteristics. Number one, ABR blocks external routes entering the area. Why would you want to do that? The reason is, if you really look at it from this area's perspective, because it has one exit point, all these 300 routes, 300 external routes that you have, these 200, these 50 over here, in order for anybody in area 10 to go out, what's the exit point for them in this particular topology? The ABR. If you have a single exit point, rather than sending all the routes over there, you have the ability to make it into a stub area where the ABR will block the external routes, type 5 routes, from getting sent into the area. Instead, it will inject a default route automatically. So still maintaining reachability to those routes, but breaking down or cutting down the routing table drastically, because I had a whole bunch of external routes and there's a single exit point. I don't need them to have the route because I'm going to send them a default gateway. So the characteristic of this type of route, this type of area, is known as a stub area. And the two characteristics, ABR blocks external routes, which are what? Type 5 entering the area. ABR injects a default route, which is a type 3. Okay? If that's the case, what happens to my routing table over here? Help me out. What does my routing table look like now after I've made it into a stub area? What would it look like? How many O routes? Still 100. I can't do anything with the O routes. How about OIA routes? $176. Why? The extra type 3 route, the default gateway, will be added. No external routes. That's the whole purpose. So I went down from what? 575 routes to 276 routes. So I cut down my routing table drastically. Not only that, if there was a flapping route in an external domain, I don't need to worry about it because I'm not getting the route into this area anyways. Do you get my point? That's a stub area. That's it. That's what a stub area is. These two characteristics. $175 inter-area routes, 25 plus 150, right? Plus the default route, which is a type 3 route getting injected in. So Shant, if you already have a default route, is there in stub area for another the effect of the default route? See, if you do a default route injection using the OSPF default information originate, that doesn't make it into a stub area. Stub area's characteristics are the two areas, right? Two things. One is what? Block the type 5s, and then the other one is to inject the default route. So you can do an injection of a default route, but you don't need to if you're making it into a stub area. You don't need to manually go in and issue the command because the stub area would automatically do that. Does that make sense, Ashan? So you would do a default information originate if there's certain routes that you just default information originate is, I'll show you where you might want to use it, not over here. There's no need for it. Correct. You would still get the two. Let's say that you didn't have external routes at all, but there is still a reason for doing that. I'll show you that in a second. You guys okay with this? Now, how do I configure it? To configure the route, configure a stub area on all routers within the area, including the ABR, router OSPF1 area, whatever area it happens to be, stub. All the routers need to agree that this is a stub area. That means I'm not going to be getting any type 5 routes from my ABR. Instead, the ABR will inject the default route, the two characteristics that I put on the top. So this would be your characteristics, actually, because it's 2. And this would be the configuration of it. So this is how you configure it. This is the characteristic of it. Good? Clear? Now, one thing that you need to understand, how important is that all the routers in the area configure themselves as that particular area as a stub area. In order for two routers to establish a neighbor relationship among themselves, if two routers need to establish a neighbor relationship with each other, there's certain fields that need to match. There's 6 fields in the hello packet. Need to match. What are the 6 different fields inside a hello packet that need to match? For two routers to establish a neighbor relationship, if the 6 packets don't match, the neighbor relationship will not even established. What are those 6 fields? Anybody? Inside the hello, what are the 6 fields? Area ID, no network, not network type. You can still establish a neighbor relationship and have different network types. The timers, the hello and dead, both have to match. So that's 3. What else? Authentication. Subnets and IP addresses, I'm assuming you need to have this, they need to be on the same segment. So if they're not on the same segment, you won't be able to establish a neighbor relationship anyways. MTU. And the last one is known as a stub area flag. These are 6 fields that need to match. Passive interface, all it does, it will not send or receive an update. It's not a field inside the hello packet. So if I'm sending a hello to a neighbor to establish a neighbor relationship, I need to have these 6 fields which are inside your hello packet to match. If you do a passive interface, I'm not going to send or receive a hello packet on the interface. All right. Out of them, one of them, you can ignore this, especially if you have, let's say this was a switch running OSPF. Switches, depending on what type of switches you're running, sometimes they have to change their MTU. For jumbo MTUs, All right. If they have changed the MTU and the router is still running the 1500 MTU size, you're going to have a mismatch. You have the ability to go over here on the switch or on the router and issue a command called the IP OSPF MTU ignore, which is common. Because when you establish OSPF between a router and a switch, the MTU mismatch happens on a regular basis. And one of the symptoms of this is if you see your neighbor relationship going all the way to xstart in the states of OSPF and going down, coming back to xstart and down, back to xstart and down, that's an indication that you have an MTU mismatch. Keep that in mind. So if you ever see that your neighbor relationship is flapping, it goes to xstart and comes back, goes to xstart and comes back, generally the problem is your MTU mismatch. All right, so you do have the ability to ignore that, but the other 5 fields that you have, area ID, hello, dead, authentication, stub area flag, these 5 need to match. There's no ways getting around that. Everybody okay with that? What is a stub area flag? What that basically means, if this guy is saying this area 10 is a stub, and this guy is saying, no, it's a normal area, they will never establish a neighbor relationship. So every router in the area, including the ABR, because ABR is also part of that area, needs to say that this is a stub area. Anybody that doesn't, that router will be isolated. Everybody okay with that? Clear? Let's do that over here real quick. Let's go and set up area 10 as a stub area. Let's do a before and after. Show IP route on router 4. It's got a whole bunch of routes. Let's do a include OE2. See, a whole bunch of external routes and no default gateway, right? I want to make it into a stub area. As soon as I do this, area 10 stub, you'll notice the neighbor goes down and it will not come up. This guy, router 2, will take some time for it to go down because it has that 40-second hello time, dead time. It's already down to 25. It's going to keep on going down and eventually kill it. Why? I've done the OSPF area type as stub on what? On router 4. On router 2, on that particular interface, it still says area 10 is a normal area. So eventually this neighbor will go down and won't come up until you go in and say what? Area 10 is a stub. So that stub area flag needs to match. And as soon as I do that, my neighbor relationship should come up. But now when it comes up, if I go back to router 4, remember those show commands that I did? Let's do the same show commands again. Show IP route. Now you'll notice at the top, you see a default gateway. So I have a default gateway and my external routes are gone. Can I still reach them? I can still reach my external routes. What are these routes? If you take a look at it over here, wrong one. If you look at it over here, this is the 8, the 7, and the 9s. Everybody okay with that? You guys okay with the stub area? You know, you understand the characteristic of a stub. Yes? Then I'll show you the other one. Good. The next one is called a totally stubby area. First thing that you need to understand is it's not a full area, it's an extension, it's a sub area. It is an extension of the stub area. So it's not an area type, it does not have its own flag. The flag is still stub, it's just an extension. Okay, what do I mean by it's an extension? That means the two characteristics that I told you about over here, it has those two already built in. So you need to be a stub area before you can be a totally stubby area. All right, it's an extension of the stub area. What do I mean by it's an extension of the stub area? It means those two characteristics are there, plus it also has one extra. If I already have a default gateway pointing out over here, if I have a default gateway pointing out through the ABR, do I really need to have the inter-area routes? You understand what I'm saying? If I already have a default gateway pointing to R2 saying, if I don't know the route, I'll send it to R2. Why do I even bother with what? Other routes, the other 175 routes. I have the ability, if I've already done it, made it into what? A stub area that's injecting a default route in, I can do what is known as a totally stubby area, in which I will not only block my type 5s coming in from here, here, and here, I'm also going to block any routes from the other areas, IA routes, which are type what? 3s. If that's the case in my example over here, what have I done to my routing table? Help me out with that. Let's put a different color. How many O routes? O routes don't change. The default route is still 1. It's still an OIA route. So I've cut it down to 101 routes. So went from 575 routes. I went from 575 routes to 276 routes by making it into what? Stub area. And I've further cut down another 175 routes by making it into a totally stubby area. Besides the advantage of flapping routes not affecting me. So rather than doing summarization, if I'm planning on doing something like that, it's easier or better to just make it into a totally stubby area. What you cannot have is you cannot block type 3 and allow type 5. That is not possible. If you want to block 3, you will also block 5. Do you get my point? This is not possible. So if you're blocking 5, then you have an option of also blocking 3, not the other way around. So by doing that, your routing table is very concise. It's just got the routes within your own local area and a default gateway pointing towards what? My ABR, and he'll get me to wherever I need to go to. The filtering is not possible for the backbone area, area 0. You guys good with that? So let's finish your write-up on this. Totally stubby area, it's an extension of the stub area. Blocks what? ABR blocks type 3 or summary LSAs. from other areas entering the totally stubby area. So it will have the two characteristics. What are the two characteristics above over here? ABR blocks 5s, injects a default route, plus it's going to have what? This extra thing. Again, it's not a full area. It's a sub area of the stub area. So the configuration is only required on the ABR. So I should say this, only on the ABR. So if I knew I was going to do this, I don't need to do it in 2 steps. I do area X stub on all the other routers, and I say area X stub, no summary, on the ABR. Only on the ABR. You don't do this on what? The internal routers. Only on the ABR. Does that make sense, guys? And what would happen? All your inter-area routes will be gone. Is it possible to make area normal and on ABR filter type 3s and allow type 5s? Yes, you can do that. Yes, you can do that if you want to. But that's not an area type. That's a manual way of doing it. That's basically filtering rather than doing an area type per se. Good? Clear? So if you really look at it, I haven't shown you 2 area types. I've just shown you 1. The other one is a sub area. Sheet time requirement comes, meaning? Yeah, absolutely. Yeah. So this is a stub. This is a totally stub. It's a sub area of the stub. It's not an area by itself. Clear? Everybody okay with that? Now, taking it one step further, can I make this area into a stub area? Stub area means what? No type 5. Agreed? So if I make it into a stub area, that means I will not be able to inject what? RIP routes. Everybody will lose connectivity towards the RIP routes. So if an area has an internal ASBR in there, within the area, if that's the case, you cannot make it into a stub area because then you will lose connectivity towards what? The RIP routes completely. That's where this area comes in, called the not so stubby area. Just refer to it as NSSA. I'll tell you the characteristics. But before that, I don't think we actually implemented the totally stub, did we? We had to do it on the ABR. We'll do a before and after again. Now I have a default route, some IA routes, right? My objective now is to check my IA route, a whole bunch of IA routes. I'll go to 2, router OSPF, area 10, stub, no dash summary, only on the ABR. As soon as I do that, I go over here, I've lost all the IA routes, except for the default gateway. This guy's still there. So because it's still there, I still have the ability to ping 1, 3, 5, can ping any of them. So that's this thing that I was talking about over here. This thing is done as well. Good. Now, what are the characteristics of this not so stubby area? By the way, this is a full-blown area type, unlike the totally stubby area, which was what? A sub. The next one is called the not so stubby area, NSSA. What is the characteristic? Number 1, ABR blocks type the external routes from the backbone. What are external routes? Type 5. Done? So that's the case. What happens to these routes now? These 250 routes, R3 will not send it in. What about these RIP routes? That's the second characteristic. The routes redistributed by the ASBR in the NSSA area, which is in our case router 6, will be injected in as type 7 routes. They're still external routes, but they're a different type. So when I say no type 5s, how can I have these type 5s come in? So they needed to make a distinction between these routes. So what they did was they said these routes, the routes that are getting redistributed by an internal ASBR, to fake the system, they said these are type 7 routes. Type 7 routes are nothing more than external routes, but injected in by a ASBR within a not so stubby area. So this ASBR, when he does the redistribution, because I'm going to make this router part of what? A not so stubby area. It says I'm an ASBR in a not so stubby area. So whenever I do redistribution, these routes will come in as type 7s. In the routing table, remember type 5s come in as OE2. The ASBR redistribution routes will come in as N2. Those are type 7s. Okay, but type 7 can only reside within a not so stubby area. So it will go from 6 to 5, which is in the not so stubby area. He will send it to what? 3, but 3 cannot send a type 7 into the backbone area. So what R3, the ABR, will do is he will convert them into type 5s and send them out. So the 7s will be converted by the ABR into type 5s and send it to the backbone. So these guys will still receive the RIP routes as what? Normal type 5. So they will not see any difference. So the RIP route connectivity will be maintained. So what are the characteristics? We put 2 of them. ABR blocks what? External routes, type 5s from the backbone. So the 250 routes will be blocked. Routes redistributed by the ASBR in the NSSA area will be injected as type 7 routes. Done that. The third characteristic, ABR converts the type 7 into type 5 and sends them into the backbone. And that's it. These are the three characteristics of a not so stubby area. To make you understand that, let's go back over here and tell me what the routing table will look like now. Help me out with the routing table. How many O routes? O routes should be simple. 150, right? Routes within my area. How many OIA routes? I didn't do anything with the IA routes, so it still should be 125. Agreed? This is the original one over here. 150, 125. Now, how many OE2 routes? E2 are your type 5 routes. 0. And then I will have a new type, N2, which will be your $50 RIP routes. So gives you a total of 325 routes. This is what you'll have in a not so stubby area. Good? Clear. One problem. What do you guys see the problem as? If you look at the characteristics that I showed you over here, did I mention anything about a default route? I didn't mention anything about a default route. In a not so stubby area, a pure not so stubby area, there is no default information that is injected in by the ABR. You do have the ability, like Sushant was saying earlier on, to manually do it by using default information originate command, but that's like a manual tweak. But by default, a not so stubby area, unlike a stub area, does not inject the default route. So actually lost, I'll put a note over here. You lose connectivity to the external routes from the backbone. Make sense? Why would you want to do that? Maybe there's a requirement. You don't want this area to have anything to do with external routes from the backbone or connectivity towards those routes. If that's the case, NSSA is good. But you do lose connectivity. How do I do it? Let me write it down first for you guys. This is the characteristic configurations on all routers within the area, including the ABR. You guys good with this? Everybody fine? Let's do it. Before and after, router 5 would be a perfect example. Show IP route. I see IA routes. I see E routes. I see normal O routes. Let's do the include for all of them. IA routes, E2 routes. Everything is there, right? Now, router OSPF1, area 20, NSSA. I'll break my neighbor relationship again. It's a stub area flag. NSSA, it's its own flag. So I need to go to 3. It will reset the neighbor relationship and should come back up. Good. And then on 6. Down, back up. Now, let's go back and check. No effect on IA routes. E routes, gone. What do we have instead? Some N routes. These are routes from RIP. But if you check your full routing table, no default gateway. Notice there's no default gateway over here. So if I want to ping 7777 or 77, I don't know which one I'm blocking. I'm blocking one of them. So just to be on the safe side, I'll show you both. Not going, or for that matter, 8, gone. So in a not so stubby area, I actually lose connectivity to the backbone routes. You guys good with that? Everybody okay with that? So how do I restore it? One way is to do a default information originate, or the other thing is use an extension of this. Just like totally stubby was an extension of what? Stub. There is a NSSA stub. What's an NSSA stub? Extension of NSSA means the 3 characteristics that I just discussed. ABR blocks type 5s. Internal ASBR will inject the external routes as type 7. ABR will convert 7 into 5 into the backbone. It has those 3 characteristics. Plus, it has that one characteristic that was missing for it being a stub area. Remember the 2 characteristics of a stub area? What did the stub area do? ABR blocked 5. ABR injected what? Default gateway. Agreed? This was what a stub area was. Here, out of those 2 characteristics, this one is done. ABR is blocking type 5s, but it's not blocking, or sorry, it's not injecting what? The default route. So to make it into a not so stubby stub area, all I need to do is on the ABR, have him inject the default route. That would give it all the characteristics of NSSA plus the 2 characteristics of stub, hence NSSA stub. So it has all the NSSA 3 characteristics plus the 2 characteristics of a stub. So you'll restore connectivity back towards the backbone routes. This is an extension of an NSSA area. So it's not like a different area type or a different flag. So if that's the case, you only need to change this on the device that is in question, who's injecting the default route in. So only on what? Only on the ABR. Same thing. Default information originate. When you do that, this route, this default route is injected in as a ON2 route. So this default route is not an IA route, it's a N2 route. So extension of ABR plus what? ABR injects a default gateway. This is your not so stubby stub area. So the three characteristics plus the fourth one, ABR injects a default gateway in, so you restore connectivity to your backbone external routes with the default gateway. Or what you could have done is you could have gone on to the ABR and said default information originate always. That would also inject a default route in. So Shah, remember earlier on I told you that you do have that default information originate? This is a typical example where you would use that default information originate. So if you don't want to go in and do the area X and say default information originate, which I would prefer, rather than going and saying default information originate always, that's the other alternative to that. Clear? Let's do it. Let's check it. So I lost the connectivity. So if I want to restore it, I'll go to my ABR, which is router 3, same command, and if I knew that I was going to do it, I would just have done it in the front, but I just want you guys to see the progression. That's why I'm doing it in phases. So if I do show IP route now, I should see an N route now, which is a default gateway. Everybody okay with that? Because I have a default gateway now, all these pings will work. I think 7 I'm blocking. No, it's not blocked. There you go. Everything's been sent. Any questions, guys? You guys okay with this? Everybody understand this? Should I go to the last area then? The last area is, again, an extension of NSSA. In reality, you have this. You have stub, which has an extension, which is totally stub. Then you have NSSA, which has a NSSA totally stub, and you have another one, NSSA, sorry. Then you have NSSA stub, or you have NSSA totally stub, which is an extension, again, of NSSA, not a stub extension. It goes like that. So you have two areas, NSSA and stub. NSSA has two sub areas, NSSA stub and NSSA totally stub, directly under NSSA. Not like this. This is wrong. It doesn't fall like that. I'll tell you why. What are the characteristics of a totally stub? Blocks what? ABR blocks 5. ABR blocks type 3. And ABR injects default gateway. Everybody agree? This is what a totally stub is. When I have an NSSA, this one is taken care of, right? These two are not. If I make it into an NSSA totally stub, I need to do this as well as that. Because it's a sub area, I only need to take care of it from where? From the perspective of the ABR. On the ABR, rather than doing this, I'll use a command called no-summary. What does that mean? No type 3 and no summary automatically, implicitly will also inject default gateway. I don't need the default information originate. No summary will do that for me. Let me show you. Let me do a write-up for that. Extension of an SSA, ABR blocks, type 3 routes. ABR injects a default gateway. So it's an extension of an SSA, those 3 characteristics plus these 2. Configuration only on the ABR, and all you got to do is this. No dash summary. In this case, the default route is injected as an OIA. So just to go back, I'll get rid of that on R3. Remember this? So right now, if you take a look at your OSPF configuration, you just have area X and SSA over here. Do you see that? So now if I go to router 5, my default gateway would have been pulled. So I would have lost the connectivity to this guy. Good. Now I want to make it into what? A NSSA totally stub. So all I got to do is on the ABR say no dash summary, which says no type 3 inject a default gateway. So these 2 characteristics are done by this guy. I don't need 2 commands. I don't need a default information originate to do it. This would do it. The no summary keyword does both. Blocks the type 3s and injects the default gateway instead. All right, but the default gateway will be an OIA route, unlike the other one. So where do I do it? On the ABR, area 20, NSSA, no dash summary. Now, if I go back over here, my ping will work. Not only that, if I do a show IP route, my default gateway is pointing using the IA capability. Now, the other thing is, take a look at the 9 route. Is the 9 route in my routing table on R5? Yes, it is. It's an N2 route. The same route, if I go to router 1, is an E route. That's the conversion that I was talking about. So on R1, this route over here is an E route because R3 did the conversion. Now coming back over here, let's finish the tables up. I'll save this for you guys then. Just use a different color. So this was a NSSA area. Now do an NSSA stub. So you have O as 150. OIA is not touched in a NSSA stub. Is 125. OE2 is gone. ON2, I get one extra one added because the default gateway in this guy is coming in as that. So it becomes 326. You guys good? And the last one that we had was this guy. The NSSA totally stub, O150, OIA, one, OE2, dash dash, ON2, still 50. So now I've cut it down to 201 routes. So just to give them names, the name over here was I'll just use blue. Oh no, not this one. Something dark stands out. Okay, good. If this is totally stub, and this guy over here is NSSA. This guy is NSSA stub, and this guy over here is NSSA totally stub. And I can save this for you guys. Good. And let's do it. So over here, no, we done that already. Good. We actually saw that route coming in as an OIA route. But no other IA routes over here. All the IA routes are gone. So these are the 5 areas that you have, but in reality, there's only 2. The other 2, other 3 are subs. So again, 2 main areas that you have, stub and NSSA, and then you have your totally stub, then you have your NSSA stub, you have the NSSA totally stub. You guys good? So this is the relationship that you have. The flags are only for these. Oh, it's gone. And that, guys, takes care of this, this, and this. The 2 things that I need to do for OSPF next week is virtual links and characteristics from the CCDE part. Now that you've seen the implementation, we'll do virtual links. That will finish the implementation part of it. Then we'll concentrate on CCD characteristics. How do they ask the questions? Taking a look at the characteristics and comparing them with RIP and EIGRP. That's next week. We will also be taking a look at the ISIS design next week. Probably, in all probability, we will probably finish OSPF completely, ISIS completely, redistribution completely. We might get into IPv6. If we don't get into IPv6, I have little time, I'll do BFD instead. So we'll have a lot of stuff done next week as well. You guys good? Any questions from what we did today? These area types, a lot of times you get confused with it. But if you really look at it, I've made it as concise as possible. This is the entire thing that you need to read for area types. Stub, totally stub, the characteristics and how you configure it for each one of them. If you understand that and you understand how it works, that's why I have that diagram over here. So when you look at it, it also gives you a perspective of how the different areas would change when you make it into a particular type of area, how the routes will be, how the routing table will be affected. Any questions, guys? All good then? So next Saturday, same time, not today's time, the normal time that we have. I'll be sending out the recordings. Farhan, if you don't mind, can you send me that the recording from yesterday, so I'll also post it on OneDrive, and I'll upload this tonight. Thanks. Tonight's I'll have, but the one from last night, I didn't record it last night. So I'll upload that to OneDrive, and I'll send you the link at the same time for all of you guys. In the meantime, I'll send the notes, and I'll also send the diagram that I just created right now. IOU, I'll try to do it during the week. I'll see how the speed is, and I'll do it based on that. It's a big image. Let me just show you how big it is, just to stop the IOU first. It stopped, yeah. $10.5 gigs. So it'll take a while. Download is quick. Upload, it takes a while. So probably do it, try to see what the connection is at work tomorrow, and I'll try to do it based on that. All right, guys, you guys have a good night and a good day for some of you guys. See you guys next week, Saturday, same time. Good night for IST, yep. All right, Shriram, good night. Good night, Farhan. Good night, guys. Take care. Good night, Reza. Beautiful weather over here, Reza. All right, guys, good night. Good night, Hannah. Warm is no, man. It's not warm. You come to Dubai, you'll know warm. This is cold, man. All right, take care.